Okay, next is problem number 18. Problem number 18 is about acceptance sampling. So we are given n equal to 50 and c is equal to 1, and we need to develop an OC curve. So we're going to use 0 through 10% as our P sub d value. Then we have to compute n times P sub d. So it will be 50 times 0 and 50 times 0.01, then 0.02, then 1.5, this will be 2, 2.5, 3, 3.5, 4, 4.5, 5. So these are the P sub d values, and probability of acceptance is we have to go to Poisson table, and for these n times P sub d values we have to look under c equal to 1, and I have the Poisson table right here. So first we start with 0. Okay, so that would always be 1.0, and then for 0.5 you see 0.91. Then for 1 it is 0.736. Then for 1.5 it is 0.558. Then 0.406 for 2. Then let me show you 2.5 also. 2.5 is not there. Okay, you have 2.4 and then 2.6. And when that happens, then you have to take kind of an average of these two numbers. And I have 0.288 for that. Okay, and then 3 of course is not a problem, it is there, 0.199, and then we have 3.5. Once again 3.5 is not there, so you have to take an average of these two, and I have for 3.5 0.137 and 0.092. For 4.5, once again I'm going to take an average of those two, so that's 0.061, then 0.040. So these are the P sub a values. Okay, next we have to plot, and I've already prepared the x-axis and the y-axis. Y-axis is P sub a going from 0 to 1.0, and this is P sub d going from 0 to 0.1. Okay, so we start with P sub d equal to 0, P sub a is 1. Okay, and then 0.1 is 0.91, so it'll be about over there, and for 2% is 736, so somewhere around there. For 3% it is 0.558, about there. For 4% it's 0.406, about there. 5% is 0.288. 6% is 0.199. 7% is 137. 8% is 0.092. 9% is 061 and 040. So now we connect the points, and what we have is the OC curve. Of course, when you do it with Excel, it comes out nicely like that. Okay, next question is B. We want producer's risk for acceptable quality level equal to 2%. So for P sub D equal to 2%, P sub A is 0.736. Okay. So producer's risk is probability of rejecting the lot. So we have to do 1 minus that. So producer's risk is 1 minus 0.736, and that is equal to 0.264 or 26.4%. That's the producer's risk. It's kind of high. And C is consumer's risk for LTPD equal to, now consumer's risk we want for 14%, sorry, for 14%. So for 14%, for 14% we don't have the information, so we have to now compute P sub N times P sub D is 15 times 14%, so that is equal to 7. So from Poisson table, P sub A is equal to, so now we have to go back to the Poisson table, and for 7, okay, for N times P sub D equal to 7, C equal to 1 is 0.007. So that is 0.007. So consumer's risk is the probability of accepting the bad lot. So it is 0.007 or 0.7%. So this is pretty good. Consumer's risk is pretty good, but producer's risk is high. Okay, now D, we need to compute average outgoing quality. This is the formula, and I've already written down the P sub D's and the P sub A's from the previous section. Okay. So now we have to apply this formula, and note here for us N is given as 500. So the doctor's office uses 500 thermometers. So the first one is always 0 here. Now 0.01 times 0.91 times 500 minus 50. So that's in the numerator, divided by 500. So that will give you 0.00819. Then the next one is 0.02 times 0.736 times 500 minus 50 divided by 500, and that happens to be 0.01325. And similarly we can compute the rest of them. So this will be 0.01507, 0.01462, 0.01294, 0.00860.00662, 0.00494, 0.00360. So these are the AOQ values. Okay, now we have to plot these, and we need to plot P sub D on the x-axis, so that start from 0, 0.1, 0.2, 0.4, this is 0.06, 02, 04, 06, 08, and 0.1. So these are the P sub Ds, and here we have to plot AOQ, and let me see, we need to make sure that the scaling is proper. We have to go all the way up to 0.015, a little above 0.015. So this will probably work. So that is 0.015. So that will be 0.02. And then start from 0, 0. The first point is 0, 0. So it starts out from 0, 0. And then you start plotting for 0.1. Okay, let me put it this way so we can see. For 0.1 is 0.0089. So maybe around here. Then next one is 0.01325, so maybe around there. So this is approximate. When you do it in Excel, it will be accurate. And then for 3%, it is 0.01507, so maybe it's slightly above that. For 4%, it is 0.014, so it drops down a little bit like that. And for 5% is 0.129, so about there. For 6% it is 0.0107, 7% is 0.008, so about there. 0.06, 0062, so it comes down quite significantly. 0.04 and 0.036. 0.036 is probably about there. So if you connect the points by freehand, so it comes down like that. So, and of course when you do it in Excel, it comes out like this, and the peak being AOQL. So this peak is AOQL, and we can, that's the maximum value, so we can use that 0.01507 or 1.507% is the average outgoing quality limit.